Hi guys, I wanted to do number 2 with you. I know we started it in class. For one of the classes we started it, for the other one we didn't. So number 2, I'm hoping you've gotten a chance to read it and try it on your own before you're watching the video. Number 2 is saying that we want to maximize volume. So it's a square base and the edges of the square are the same. The height is not x because this is not, it's not x cubed, it's a square prism. So the volume that we're maximizing is length times width times height. It's x squared times height. That's what we're maximizing. And now, obviously we can't go work with this volume formula until we come up with another equation that has x's and h as well. That's where the surface area plays a role. So the surface area is 108, and the surface area is the area of all 5 faces. Remember, there's no lid, there's no top. So you've got just a bottom, which the area of the bottom is x squared. Then you've got this sort of rectangle, that face. The area of this face is x times h. And then it also has a congruent face behind it, so it's x times h. Then the top is also h times x, or x times h, which is the same as the bottom. So hopefully you were able to keep a track of that. I've got 4 rectangles whose area is x times h. Here's my secondary equation. Again, this is my primary equation. If you read the strategies on top, the primary equation is what needs to be maximized or minimized. That's the equation that we're going to find the derivative of and find the local max, and local max that ends up being an absolute max. So this is what we're going to find the derivative of, but not yet because it's made up of x squared and h. So let's solve for whatever is the easiest. Please don't solve for x. We're going to have to take the square root of both sides, so let's stay away from that. Let's solve for h. I'm hoping you're already solved for h. I'm going to subtract x from both sides, and I'm going to divide both sides by 4x, and that's what h equals. I'm going to go back to my volume formula. I know that it says complete in your notebook. There's really isn't enough space, so you decide where you want to complete it. So here's my volume formula. Again, everywhere I see h, I'm going to plug that in. Here's x squared times its entire quantity. And now my volume formula that I'm supposed to find the derivative of, so I can find absolute max, is just made up of x's, which is a good thing. Let's not leave it like that. Let's distribute. Let's simplify so you don't have to do the product rule. This x squared and this x, that's going to cancel, and that will give me just an x, which I'm going to distribute. So it's 108 108x minus x cubed all over 4. And again, treat the 4 as a constant. It's a quarter times 108x minus x cubed. So no one does the quotient rule, and I'm hoping no one did the product rule. We're just going to find the derivative. I know it's hard to see. We're just going to find the derivative using the power rule. Here's a quarter that's just going to tag along. The derivative of 108x is just 108. And then the derivative of x cubed is 3x squared. And we're going to put this equal to 0. And I'm going to get 2 solutions. Again, I'm trying to find critical points here. Once I put this equal to 0, let me do this in my head. I believe we'll get positive 6 and negative 6. And again, we don't want the negative 6 because side length can't be negative 6. So my only critical point that I want is 6 because I can't let my side length be negative 6. I'm just going to confirm that really quickly. Yes. Third, yep. And now, if I plug in 7, this quantity will be bigger than 108, and which would do 108 minus a bigger number, which makes it negative. If I plug in 1, 108 minus 3 is a positive number. Oh, look, what a quinky dink. Again, only one critical point, and that one critical point ends up being the local max. That's why it also ends up being absolute max. I'm worried that you're going to think that every time you have a local max, it's also an absolute max. It's only because we only have one local max, we have no endpoints, and the local max ends up being absolute max. The derivative is positive, then my f is increasing, or my volume, and the derivative is negative, my volume is decreasing, so that local max ends up being absolute max. I'm going to let you sort of finish because they're looking for dimensions. I just found the dimensions of my base, and you need to go find the height. So far I have 6 by 6, and you go finish and find the height.